Hey there, space cadets! Ever looked up at the night sky and wondered, what's the point? No, not the existential kind. We're talking about the actual end of the universe. It's out there somewhere. But how does it all end? Does it end? We're diving headfirst into the cosmic abyss, where physics gets weirder than a cat in a box. Inside another box. Imagine a universe where stars fizzle out, black holes throw up their lunch, hawking radiation, anyone? And the very fabric of reality unravels faster than your grandma's knitting. Hold on to your telescopes because we're about to explore the mind-bending possibilities of the universe's grand finale. Let's be real, the universe is pretty old. It's been around the block a few times, seen some things. But even the oldest universes have an expiration date. How's it going to go down? A whimper, a bang, or a slow fade to black? Some scientists believe in the heat-death scenario. Everything cools down, stars burn out, and we're left with a cold, dark void. Buckle up, Buttercup, because we're venturing into the realm where the known universe gets its mind blown. Out here, the rules of the game start to get a little fuzzy. Physics is the rulebook of the universe, right? On the fringes, it's like someone spilled cosmic coffee all over those rules, and then there's black holes, those gravitational gluttons that gobble up anything close. Alright, space cadets, let's talk about the ultimate cosmic bummer heat death. Imagine a universe where the party's over, the last star has burned out, and all that's left is a cold, dark void. It's enough to make you want to curl up in a black hole with a good book, if black holes and books still existed. In this scenario, the universe keeps expanding, like a cosmic balloon that's been inflated one too many times. But here's the catch. As it expands, everything spreads out, cools down, and basically loses its pizzazz. Stars, those giant balls of nuclear fusion, eventually run out of fuel and fizzle out like a dying campfire. Now, you might be thinking, what about all that leftover heat? Good question. It's still there, but it's spread so thin that it's practically useless. Like trying to warm up a galaxy-sized swimming pool with a single match. Brrr, talk about a cosmic chill. So, what's the culprit behind this cosmic energy drain? Meet Entropy, the universe's ultimate party pooper. Entropy is all about disorder, randomness, and basically things going from exciting and interesting to, well, boring. Think of it like this. You spend hours cleaning your room, meticulously organizing your Funko Pop collection. Then your roommate walks in, trips over their own feet, and bam! Entropy strikes. Your carefully curated collection is now scattered across the floor like a cosmic yard sale. That's kind of what's happening to the universe in the heat-death scenario. Everything is slowly but surely spreading out, becoming more disordered, and losing its ability to do anything interesting. It's like the universe is slowly transforming into a lukewarm cup of tea. Now let's address the big question, can anything survive in a universe slowly succumbing to heat death? The short answer is, it's not looking good, folks. Life, as we know it, relies on energy gradients. That means we need areas of high energy and low energy to do their thing, like powering our cells or binge-watching Netflix. But in a heat death scenario, those gradients disappear. It's like trying to run a marathon on an empty stomach and a treadmill going nowhere. Some optimistic astrophysicists have theorized about super-advanced civilizations finding ways to harness energy from the ever-so-slight fluctuations in a heat-death universe. But let's be real, that's a long shot, even for a species that can build a Dyson sphere. Okay, so the universe is cooling down, everything's spreading out, and life as we know it is toast. But what about all that information? All those memories, cat videos, and embarrassing teenage Facebook posts? Does it just disappear into the cosmic ether? According to some physicists, the answer might be a resounding nope. Remember that whole entropy thing? Well, it turns out that even though entropy is all about disorder, it can also lead to the creation of complex structures like snowflakes or, you guessed it, black holes. Black holes are like the ultimate cosmic hard drives, storing vast amounts of information within their event horizons. And guess what happens when black holes eventually evaporate? That's right, they release that information back into the universe, albeit in a scrambled and probably unusable form. It's like trying to piece together a jigsaw puzzle after your dog used it as a chew toy. Alright, cosmic comrades, let's talk about something even weirder than a black hole eating a galaxy for breakfast: proton decay. Yeah, you heard that right, those tiny little particles that make up, well, everything, might not be as eternal as we once thought. Talk about a real downer. It's like finding out your favorite band is breaking up. Permanently. You see, for the longest time we thought protons were like the ultimate survivors. They're the building blocks of atoms, the very essence of matter. They've been around since the Big Bang, just chilling in the hearts of stars, holding your coffee mug together, everyday proton stuff. But then, some party-pooping physicists came along and said, hold on a minute, what if protons decay? Imagine the look on everyone's faces. It's like saying your grandma's vintage china collection might spontaneously turn into dust bunnies. Not cool. Universe, not cool. Now, why would these physicists even suggest such a thing? Well, it all comes down to something called grand unified theories, or GUTS for short. Don't let the name fool you, these theories are all about shaking things up in the world of physics. GUTS are basically physicists' attempts to find a single elegant theory that explains all the fundamental forces of the universe. Think of it like trying to find the ultimate universal remote control, one that can change the channel on your TV, order pizza, and maybe even control the weather. These GUTS predict that at extremely high energies like the kind that existed just after the Big Bang, the forces that govern the universe might have been unified. And one of the consequences of this grand unification is that protons, those seemingly indestructible particles, could actually decay into lighter particles. And no one wants to live in a universe where even the atoms are having an existential crisis. So, how do we catch a proton in the act of decaying? Well, that's the tricky part. You see, proton decay, if it happens at all, is an incredibly rare event. We're talking about lifetimes longer than the age of the universe itself. It's like trying to win the lottery, twice in a row while being struck by lightning, on your birthday. But physicists are a persistent bunch. They've built giant underground detectors like Super Kamiokande in Japan, filled with tons of ultra-pure water, hoping to catch a glimpse of a single proton deciding to call it quits. It's like building a cosmic-scale security system, complete with laser beams and motion sensors, all to catch a single, incredibly slow and possibly non-existent thief. So far, no luck. But hey, that doesn't mean we should give up hope. After all, the universe is full of surprises. Maybe, just maybe, one day we'll catch that elusive proton taking its final bow. Now you might be thinking, okay, so protons decay. That's depressing. Does everything just disappear into nothingness? Well, not necessarily. Even in the face of proton decay, the universe keeps things interesting. Those lighter particles protons decay into, they interact, creating new particles and structures. So while proton decay seems like a bummer, it could mean new wonders await. Alright, fellow space explorers, let's talk about the ultimate cosmic weight loss program: black hole evaporation. Yeah, you heard that right. Those all-consuming monsters of the cosmos, those gravitational gluttons that gobble up anything that ventures too close, well, they've got a bit of a weight problem themselves. It's like finding out your vacuum cleaner has a dust allergy. You see, for the longest time we thought black holes were the ultimate one-way street. Stuff falls in, gravity does its thing, and that's that. Game over, man. No refunds, no exchanges. But then, along came Stephen Hawking, the cosmic party crasher himself, with a mind-blowing theory. Black holes aren't so black after all. Turns out these cosmic behemoths aren't just sitting there, passively swallowing everything in sight. They're actually leaking energy, slowly but surely, like a cosmic coffee mug with a tiny invisible crack. And this, my friends, is where things start to get really weird. And by weird, we mean mind-bendingly awesome. So how does a black hole, an object so dense that not even light can escape, manage to lose weight? Enter Hawking radiation, the universe's strangest diet plan. Sometimes one particle gets sucked in, while the other escapes. The escaping particle steals energy, causing the black hole to lose mass over time. Did someone lose the cosmic blueprint? Black holes evaporate. No big deal, right? Not so fast. Hawking radiation creates a cosmic conundrum, like solving a puzzle with pieces replaced by cat pictures. Quantum mechanics says information can't be destroyed, it might get scrambled, but it's always there. With Hawking radiation, things get fuzzy. Escaping particles carry energy, but no information. Is information truly lost in a black hole? The black hole information paradox solved? The paradox has sparked debates and wild theories for decades. Recently, a potential solution has emerged. Some believe information isn't lost in black holes, it's encoded in Hawking radiation. Quantum entanglement might hold the key. The universe is weirder and more wonderful than we imagined. Section 1. The Runaway Universe. Hold on to your cosmic hats, folks, because things are about to get really strange. We've talked about heat death, proton decay, and black holes throwing up their lunch. But now, let's talk about the universe's ultimate cosmic prank, dark energy. You see, for the longest time, we thought the expansion of the universe was like a car slowing down after a big race. You know, the Big Bang gave it a kickstart, but eventually gravity would put on the brakes. Everything would cozy up again, maybe even lead to another Big Bang. A neat, cyclical cosmic story. But then, some pesky astronomers decided to measure just how fast the universe is actually expanding. And guess what they found? It's not slowing down at all. It's speeding up, like a cosmic joyride with a lead foot on the gas pedal. And the culprit behind this cosmic acceleration? You guessed it, dark energy. Now here's the thing about dark energy. We don't really know what it is. Some scientists believe dark energy is a property of space itself, a kind of cosmic anti-gravity. But what if dark energy isn't constant? What if it's getting stronger over time? This could lead to a scenario known as the Big Rip, where space-time is torn apart. Now let's add another layer of cosmic weirdness to the mix: quantum mechanics. You see, in the world of the very small, things don't quite follow the same rules as they do in our everyday macroscopic world. Particles can be in multiple places at once, information can be teleported, and cats can be both alive and dead. Sorry, Schrödinger. So what happens to these quantum phenomena as the universe approaches its grand finale? Well, that's where things get really interesting. Some physicists believe that quantum effects could become amplified in a dying universe, leading to some truly mind-boggling scenarios. Imagine a universe where quantum fluctuations, those tiny ripples in the fabric of reality, become so powerful that they create new universes. Or a universe where time itself becomes granular, like a cosmic DVD skipping on its final frame. It's enough to make your head spin faster than a neutron star. Speaking of time, let's talk about one of the universe's biggest mysteries, the arrow of time. Why do we experience time flowing in one direction, from the past to the future? Why can't we remember the future or unspill a glass of cosmic latte? Some physicists believe that the arrow of time is linked to the expansion of the universe. As the universe expands, entropy increases and things become more disordered. This creates a kind of cosmic arrow pointing from a more ordered past to a more chaotic future. But what happens when the universe reaches its end? Does the arrow of time reverse? Does it stop altogether? Does it even matter if there's no one around to experience it? These are the kinds of questions that keep cosmologists up at night, pondering the nature of time while sipping their quantum coffee. So we've talked about heat death, the Big Rip, proton decay, and the weirdness of quantum mechanics at the end of time. It's enough to make you want to curl up in a black hole with a good book. If black holes still exist, that is. But before you give in to cosmic despair, consider this. What if the end of the universe isn't the end? What if it's just the beginning of something new? Some physicists believe that our universe might just be one in an infinite cycle of cosmic expansion and contraction. Imagine a universe that collapses in on itself in a big crunch, only to be reborn in a fiery explosion of creation. Or a universe that gives rise to baby universes through quantum fluctuations, each with its own set of laws and possibilities. It's a mind-blowing concept, but hey, in a universe where physics gets weird at the end, anything is possible. Alright, space cadets, buckle up because things are about to get messy. We're diving headfirst into the Big Rip, a cosmic theory that's basically the universe's version of a messy divorce. Think galaxies flying apart faster than your Aunt Carol can down a bottle of Chardonnay at a family reunion. It ain't pretty. Remember dark energy, that mysterious force pushing the universe apart? Well, in the Big Rip scenario, dark energy gets a serious case of road rage. It's like it throws the cosmic car into overdrive, accelerating the expansion of the universe at an ever-increasing rate. Imagine a balloon being inflated so fast that it doesn't just pop, it shreds itself into a million tiny pieces. That's kind of what happens in the Big Rip. Galaxies are torn asunder, stars are scattered like confetti, and even atoms themselves are ripped apart. Talk about a bad hair day for the cosmos. Now let's talk about a less dramatic but equally final theory, the Big Freeze. Imagine a universe where the party's over, the last star has burned out and all that's left is a cold, dark void. In the Big Freeze scenario, the universe keeps expanding, but instead of ripping itself apart, it just slowly winds down. Stars use up their fuel, galaxies drift farther apart, and the universe slowly cools down to a temperature just a smidgen above absolute zero. It's like the universe is taking a deep breath, relaxing after billions of years, and finally drifting off into a peaceful cosmic slumber. Okay, so we've talked about the universe ripping itself apart and the universe slowly freezing to death. Now let's talk about a theory that's a bit more retro. Think cosmic bell-bottoms, disco balls, and the universe doing the hustle, the Big Crunch. It's the theory that's so crazy it just might work, or not. In the Big Crunch, gravity pulls everything back together. Galaxies merge, stars collide, and the universe gets denser. What happens at the end? Maybe another Big Bang, or just a big messy cosmic reset. Hold on to your cosmic hats, folks, we're talking about the multiverse. The idea that our universe isn't the only one out there. Imagine a vast cosmic landscape where universes bubble up like foam in a bathtub. In the multiverse, anything is possible. Let's talk about quantum foam and baby universes. It's like a cosmic daycare with universes popping in and out of existence. In quantum mechanics, empty space isn't actually empty. It's a cauldron of virtual particles, popping in and out. These fluctuations could give rise to baby universes. Imagine a tiny bubble of spacetime expanding into its own universe. The universe blowing cosmic bubbles, each a potential new world. Alright, cosmic chrononauts, let's talk about everyone's favorite frenemy time. It's the thing that makes you late for work, keeps your wrinkles company, and generally makes you question your life choices. But in the grand cosmic scheme of things, time is even weirder than you thought. You see, in our everyday lives, time seems like a pretty straightforward concept. It marches on at a steady pace, like a metronome on a mission. But throw in a black hole or a healthy dose of cosmic expansion, and time starts acting weirder than a cat in a laser pointer factory. Einstein's theory of relativity tells us that time is relative, like your crazy Uncle Bob after a few too many eggnog lattes. It can speed up, slow down, or even warp, depending on your speed and the gravitational forces at play. It's enough to make you want to throw your watch out the window and just go with the cosmic flow. Now let's talk about the cosmic forces that make the universe tick, those invisible puppet masters pulling the strings of reality. We're talking about gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. Think of them as the Fantastic Four of physics, each with their own unique superpowers and a penchant for cosmic drama. Gravity, the strong silent type, keeps our feet on the ground, most of the time, and holds galaxies together. Electromagnetism powers our light bulbs, controls our smartphones, and generally makes our modern lives possible. The weak nuclear force governs radioactive decay, like that banana in your fruit bowl that's about to go supernova. Not really, but you get the idea. And then there's the strong nuclear force, the real powerhouse of the group, holding atomic nuclei together tighter than a pair of skinny jeans after a Thanksgiving feast. It's like the cosmic glue that keeps everything from flying apart. Now, here's where things get really interesting. These four fundamental forces might seem like separate entities, but physicists believe they're actually different aspects of a single unified force. Think of it like a cosmic symphony, where each force is a different instrument playing in perfect harmony. In the earliest moments of the universe, just after the Big Bang, these forces were supposedly united in a grand cosmic orchestra. But as the universe expanded and cooled, these forces went their separate ways. Section 4. Unification, the ultimate physics challenge. Ever tried to solve a Rubik's Cube while riding a unicycle on a tightrope? That's what it's like for physicists trying to unify the fundamental forces. It's the holy grail of physics, driving scientists bonkers for decades. They've come up with wild ideas like string theory and loop quantum gravity. These might unlock the universe's deepest secrets. Reflections on our place in a finite universe. We've journeyed to the edges of the universe and back, exploring mind-bending theories. It's enough to make you want to grab a cosmic cocktail and contemplate life. Facing the universe's ultimate demise, whether a fiery big rip or a chilling big freeze, forces us to confront our own existence. Section 2. The meaning of it all. The universe, with its vastness and its mysteries, doesn't come with a user manual or a handy FAQ section. We're left to ponder the big questions on our own, armed with our curiosity, our telescopes, and maybe a few too many cups of cosmic coffee. If the universe does have an ultimate end, does that mean our lives are ultimately meaningless? If everything we know and love will eventually be consumed by a black hole, ripped apart by dark energy, or simply fade into the cosmic background radiation, what's the point of it all? It's a question that has haunted philosophers, poets, and physicists for centuries. And while there's no easy answer, perhaps the search for meaning is more important than the answer itself. After all, it's the questions we ask, the mysteries we explore, and the connections we make along the way that give our lives purpose and richness. Section 3. Beyond the horizon. What lies beyond the end of the universe? If the universe does have an end, what lies beyond that cosmic horizon? Is it a void of nothingness, a realm beyond our comprehension, or something even weirder than we can imagine? Some physicists, armed with their equations and their boundless imaginations, have proposed some truly mind-bending possibilities. Perhaps our universe is just one bubble in a vast cosmic foam, a multiverse teeming with an infinite number of other universes, each with its own set of physical laws and possibilities. Or maybe the end of our universe is simply the beginning of another, a cosmic cycle of death and rebirth that repeats for all eternity. It's enough to make you question everything you thought you knew about reality and wonder if we're just characters in a cosmic video game, controlled by some interdimensional teenager with a joystick and a serious case of boredom. In the grand cosmic narrative, we may never know the answers to these metaphysical questions, but that doesn't mean we should stop asking them. The search for knowledge, for understanding, for meaning, is what makes us human. As we continue to explore the universe, unravel its mysteries, and push the boundaries of our understanding, we should embrace the unknown. The universe is a vast and wondrous place, full of surprises and wonders that we may never fully comprehend. And while the end of the universe may seem like a distant and abstract concept, it's a reminder that our time in this cosmic playground is precious. So let's make the most of it. Let's explore, let's question, let's marvel at the beauty and the strangeness of it all. Because even though the universe may have an end, the story of our curiosity, our thirst for knowledge, and our enduring sense of wonder will continue long after the last star has faded away. Well folks, we've reached the end of our cosmic journey, explored the weird and wonderful ways the universe might end, from a grand, messy divorce in the Big Rip to a chilling cosmic slumber party in the Big Freeze. We've pondered proton decay, black hole indigestion, and the universe's ever-expanding waistline, all fueled by that mysterious cosmic dark chocolate dark energy. It's been a wild ride, full of mind-bending theories, existential angst, and enough cosmic jargon to make your head spin faster than a neutron star in a blender. But through it all, one thing remains clear. The universe is a weird, wonderful, and utterly unpredictable place. Just when we think we've got a handle on things, some new discovery comes along to shake things up, like finding out your favorite cosmic coffee shop has replaced all its baristas with robots that only serve quantum foam lattes. Contemplating the end of the universe can be a humbling experience. It reminds us that we're just a small part of something much larger than ourselves, like that last slice of pizza at a cosmic buffet. But instead of succumbing to existential dread, we should embrace this cosmic perspective. It's a reminder to cherish the moments we have, to appreciate the beauty and wonder of the universe around us, and to never stop asking questions, even if those questions involve black holes, time travel, or the meaning of life, the universe, and everything. After all, in a universe where everything is constantly changing, evolving, and eventually fading away, the very act of seeking knowledge, of exploring the unknown, and of pushing the boundaries of our understanding is perhaps the most meaningful thing we can do. So, the next time you find yourself gazing up at a star-filled sky, take a moment to appreciate the vastness and mystery of it all. Remember that those twinkling points of light are distant suns, some perhaps harboring planets of their own, where other beings might be looking up at the same cosmic expanse, pondering the same existential questions. And who knows, maybe somewhere out there in a distant galaxy far, far away, there's a civilization that's figured it all out. They've solved the mysteries of dark energy, unlocked the secrets of time travel, and even found a way to make pineapple on pizza actually taste good. But even if we never find those cosmic neighbors, even if we never unlock all the universe's secrets, the journey itself is what matters. So keep looking up, keep asking questions, and keep exploring the weird, wonderful, and utterly mind-blowing universe we call home. Because even though the universe might have an expiration date, our curiosity, our sense of wonder, and our thirst for knowledge, those are the things that will truly last forever.